Okay, so now we're going to practice finding maximums and minimums and concave up, concave down, increasing, decreasing intervals. And so some of this you're going to have to go back to your old information in your brain. So the first thing we have to do is find the intercepts. And when we're talking about intercepts, we're talking about x-intercepts and y-intercepts. Okay, so x-intercept and y-intercept. You need both. Remember, for x-intercept, that's when y is equal to 0. And for the y-intercept, that's when x is equal to 0. Okay, I kind of like the y-intercept because it's so easy. So if I put in a 0 here, I get 4 times 0 and then 3 minus 0 squared. Well, that's going to end up being 0. So the intercept is the origin 0, 0, which also means it's the intercept over here, at least one of them, for the x-intercept. Remember, there's only one y-intercept if it's a function. Only one y-intercept if there's a function. There can be multiple x-intercepts. And this one is nice because it's already factored for us. So either 4x equals 0 or 3 minus x equals 0. So x equals 0, that's what we were expecting from the y-intercept. And this one, x equals 3. So we have two x-intercepts. So we have the origin and we have the point 3, 0. So we have the intercepts for our function. And now, and make sure you label them so that I know that you know which is which. And write them as points. I'm pretty sure it'll say that for you, but always write them as points. And then we have to find the increasing and decreasing intervals. Well, that's where we need to take the derivative. And you could use your product rule if you wanted to, or you could multiply it out. It really doesn't make any difference to me. I am personally going to multiply it out because I don't want to do the product rule. So 4x times 9 minus 6x plus x squared. And then I'm going to distribute my 4x and get 36x minus 24x squared plus 4x to the third. Okay, this is way easier for me to take the derivative of than using my product rule. So the derivative of this is going to be 36 minus 2 times 24 is 48x plus 12x squared. Now remember, we have to find where these are positive, negative, or 0. So usually we find where the derivative is 0. Remember, those usually are maximums or minimums, or maybe an inflection point. So the first thing I notice with this is that I have a 12 in all of those. So I'm going to factor out the 12 and end up with 3 minus 4x plus x squared. I'm going to set that equal to 0 to find my critical points. So the 12 is really immaterial, so I'm going to factor. The only factors of 3 are 3 and 1, and the middle term is negative, so I know that they both have to be negative, equals 0. So that means x equals 3 or x equals 1 if I set those equal to 0. And this is where I do my number line. Put 1 to the left because it's smaller than 3. And then I need to find values of the function. Okay, so I might pick 0. And if I do f prime of 0, that's easy to do. That's 36. That's a positive number. If I do f prime of 2, I need a number in between 1 and 3. I might do 2. So that would be 36 minus 48 times 2 plus 12 times 4, because that's squared. And I don't have that number. Let me quick do it on my calculator. 36 minus 48 times 2 plus 12 times 4. I'm pretty sure this is going to be negative. Yep, it's a negative 12. But I really only care that it's negative. And then for this last interval, I need to pick a number that's greater than 4. So I'm just going to do f prime of 4 because that's going to be the smallest. So I'm just going to type it into my calculator. 36 minus 48 times 4 plus 12 times 4 squared, which is 16. And I end up with positive 36. Okay, so this is positive 36. And that's the important thing. Positive, negative, positive. So that means the function is increasing in that first interval, and then it's going to be decreasing in that second interval, and then it's going to be increasing in the third interval. And you can kind of already get the idea. So increasing has two intervals. Increasing are the outer ones, so negative infinity to 1 and 3 to positive infinity. And decreasing is in between 1 and 3. Okay? All right. So now I have to find max and mins. Well, looks to me like I can tell by the increasing and decreasing what's going to be the max, what's going to be the min. So it looks to me that at f of 1, right, because this is going to be 1 right here, 1, and this is going to be 3. At f of 1, that's going to be my maximum, and at f of 3, that's going to be my minimum, and those are locals, looks like. So looks like my maximum is going to be f of 1. So go back to f. So that's 4. Let me just, I think I still have it saved. Yep. So if I do f of 1, maybe I'll make this a little bit smaller so that it fits here better. So f of 1 is going to be 4 times 1, and then 3 minus 1 squared. 3 minus 1 is 2. 2 squared is 4, so 4 times 4 is 16. So f of 1 is 16. That's my maximum at the point 1, comma 16. Remember, the number inside the parentheses is the x. My minimum looks like it should happen at 3. So here's my function again. And if I do f of 3, 4 times 3, 3 minus 3, oh, that's nice. That's 0, so this is 0. So f of 3 is 0. I probably already knew that. So the point 3, comma 0 is my minimum. So it must do this if I were to graph it, and it must be sitting tangent on that point right there, if I were to guess. Okay, and now concave up and concave down, that has to do with the second derivative. Okay, so I'm going to take this first derivative that I have right here, that I did earlier. I'm going to copy that, and for my concave up and concave down, I have to find the second derivative, which is not hard, and then set it equal to 0. So second derivative is going to be, well, that's going to be 0. This is going to be minus 48 plus 24x. So I set that equal to 0. Negative 48 plus 24x. There's only an x, so I'd add equals 0. Add 48 to both sides, so 24x equals 48. Divide by 24, so x equals 2. That's where it changes the whole concavity. So if I'm thinking about my graph, where am I again? So right in here, I'm going to change colors just for a minute. Right in here at x equals 2, that's where it changes the concavity from concave down to concave up. Okay, and I can also do that with my number line. With my, with the number line here, I can put 2 in the middle. I pick a value to the left. Let's just pick 0. So f double prime of 0 is negative, because it would be negative 48. And then f double prime of, I don't know, it doesn't really matter. Anything is going to be positive. I'm going to pick 10 because I can do that in my head. Negative 48 plus 240, obviously that's a positive number, right? So concave down is from negative infinity to 2, and concave up is going to be from 2 to infinity. So that means at 2, that's my inflection point. Okay? All right, I think that's all for now. I'll do the other one in another video.